Hi everybody, Mr. Bowman here. In this video we're focusing on all the excellence questions from that 2022 exam. Let's get straight into question number 52. We've been asked to find the equation for P in terms of Q. So just to clarify what that means is, so the equation for P, so that means it's going to be P equals, and you're going to have some other stuff which involves the Q that is sitting inside that equation. So let's get into this. Let's just start off by writing down the questions. We've got 9 times 3p plus q, and that there is equal to 27 to the power of 2q. So initially when I like this, I can see the unknowns are in the powers, so these are going to be exponential equations. And my strategy for exponential equations, just an easy example to see it, is I need to simplify the expression so I've got the same base. I've used 2 in this example. I need to cancel out the bases, leaving me with the powers. In our case, our powers will be a bit more complicated, but that's kind of what we're aiming for. And I also like this question because I see 3, 9, and 27, and they're all powers of 3. So 3 to the power of 1 is 3, 3 squared is 9, and 3 cubed is 27. So I'm going to change out the 9 and the 27 to be 3 squared and 3 cubed. So that 9 is going to become 3 squared. I'm going to times that by 3 to the power of p plus q. And then that 27, important here, I am going to wrap it around in a bracket just to make the next step a bit easier on myself. So that's 3 cubed, all of that to the power of 2q. The next example, because I've got the same base power here, that being the 3, I can add together the powers. An example of why we're doing that. So x squared times x to the power of 3, that becomes x to the power of 5. So x stays the same, and we add the powers together. So we need to do that here. So that's going to become 3 to the power of p plus q, and then we're going to go plus 2. And the next one here, another example to illustrate this. So let's say we had x squared to the power of 4. That becomes x to the power of 8 because we multiply that 2 and the 4 together. So we need to multiply the 3 and the 2q together. So that's going to become 3 to the power of 6q. I've now got the same base number, and that was my goal like I talked about at the beginning here. I'm now going to cancel them out. So I'm cancelling out the 3's. So that's going to become p plus q plus 2 equals 6q. And this is when I need to think about what I'm doing. Up the top we mentioned we need p equals something to do with q. So I'm going to leave the p on this side, and I'm going to move everything to the other side. So I'm going to do minus q, and then minus 2, minus 2. So those will cancel, leaving me with p equals 5q minus 2. And that's our answer for this one. We are now on to question number 53. Show that if you add the square numbers of 3 consecutive even numbers and then subtract 2, always results in a multiple of 2. So there's going to be quite a bit to this question. So just to get me started, I need to think about this 3 consecutive even number nonsense. And this time around, we can't really just go x equals the first even number because, well, x could be 3, which means it's not an even number. So we need to be a bit more specific. In this case, we're going to let 2x be the first even number. And that's because if we multiply something by 2, it will always be even. Even number. Forgive me for that small pause. My pen had a bit of a glitch. The next even number would have been 2x plus 2. So that there's going to be the second even number. And then 2x plus 4, that's going to be the third even number. So we've got all that. So we have asked, or we have been told, it's a bit hidden there, we need to add them all together and then subtract the 2. So let's form that expression. And then I guess the other thing I forgot to emphasize is the squares of these. So we need to put them all in a bracket. So we're going to have 2x squared. We're going to add the next one, which is 2x plus 2. That's going to be squared. And then finally, we need to add them together. 2x plus 4 squared, and then we're going to go minus 2. So that's my expression here. And now what I need to do is I need to get back to this proof here. I'm looking to show that this is always going to be a multiple of 2 no matter what. So our job here, I'm thinking my final answer is going to be 2 with something to do with a bracket. And because we're multiplying it by 2, that shows it's always a multiple of 2. So that's my end goal. So my first step is I'm going to need to expand all these brackets. I'm going to need to simplify everything, see what I get. So first bracket is going to be 4x squared. And then the second bracket, I'm just going to rewrite this out as a double bracket because I worry I'm going to make a little math error. So I always do this. And then we've got plus 2x plus 4. There's another 2x plus 4. And then we've got minus 2. So I'm now looking to expand both of these middle sets of brackets. I'll be using the rainbow method as I always do in these videos. 4x squared, we're going to go that times that. So that's actually another 4x squared. And then we've got that times that. That's 4x. And then we've got that times that. Another 4x. And then we've got that times that. Plus a 4. Same over here. We've got plus 4x squared. Plus 8x in this case, there's another 8x, and then finally that's a 16. And then don't forget about our minus 2. I did mark this exam a few years ago, whenever it was, or last year. Jeez, it feels like a few years ago. But that 2, a lot of people surprisingly forgot to deal with that 2 after this point. Okay, let's simplify this expression. We're going to start off with the x squared. So we've got x squared, x squared, x squared. So that becomes 12x squared. Then going to deal with the x's. I've got 4x, 4x, 8x, and 8x. So that becomes 24x. And then the numbers, I've got 4 and 16. That gets me to 20. Minus this 2 gets me to 18. So there you go, plus 18. And I'm really liking this because I can see 12, 24, and 18 all are even numbers. So they're going to be factorizable by 2. So I'm going to take out a 2, which means I need to go divide by 2, divide by 2, divide by 2. So that there is 6x squared plus 12x plus 9. And this is exactly what I said before. At the beginning of the video, I was like, my goal is going to be to have 2 with some brackets. That's exactly what I've got. So I know for sure, because of this 2, that it's going to be a multiple of 2. So let's do a little bit of an explanation. Therefore, as the expression, forgive my messy handwriting, as the expression has a factor of 2, it is a multiple of 2. There we go. So we've wrapped up this question. We are now on to question number 54. This question says a number of small squares used in the nth shape of a pattern is given by this number here. So we've got n squared minus 2. Show the difference between 2 consecutive odd numbers. So this one here is going to be a bit tricky. We're going to have to do something similar to the last question. So we're going to go, let's say that 2x plus 1. Just a reminder where that came from. 2x was our expression for the first even number, and adding 1 to an even number gets us to the next odd number. So 2x plus 1, that's going to be equal to the first odd number. And then after that, obviously the next one is going to be plus another 2, so that's going to become 2x plus 3. 2x plus 3, and that's going to be the second odd number. So we've got that there. We now need to think about this square expression that they gave us. So just a reminder that in our case, the first square, so we'll call it n1 being the first square, that's going to be equal to 2x plus 1. And the second one, And the second square, n, would have been 2x plus 3. So because this number is going to be bigger than this number, what we need to do is we need to find out, well, what is this square minus this square? So our formula, just a reminder, is 2n minus 2, and that relates to the first square, and then we're going to take away the second square. And our n's here are different because they relate to the values that we're investigating here. So what we're going to do is we're going to substitute the first n. This is going to be the bigger one. And the second n, that's going to be the smaller one. So let's do that substitution. So this is going to look very messy. So we're going to have some square brackets. That's going to be 2x plus 3 square bracket minus 2. And all of that is then going to have the next one taken off it. And that's going to be, oh, I forgot the squared there. 2x plus 1 square bracket squared minus 2 open bracket. So we now need to expand this. Again, it's going to get very messy. So that's going to be 2x plus 3, and it's going to be the same bracket, 2x plus 3 minus 2, and then from that we're going to subtract, making the square part a double bracket to help me expand a bit easier. And then we've got minus 2. So we're now going to expand. We've got 4x squared. I might make this one a bit quicker. I might skip a line of working just to save some room. So we've got 4x squared plus 12x. If you're wondering where that 12x came from, that came from this 3 times the 2x. So that's a 6x. And that one there as well, another 6x combined, getting us to 12. 3 times 3 is 9, but we're going to minus that 2 to get me to 7. So we've got plus 7. And from that, we're going to take away, and we're not only going to do the same here, we've got 4x squared. We're then going to go plus 4x, and that's this 2x and this 2x over here. And then we've got 1 times 1 is 1, minus 2 is going to be negative 1. We're now going to expand this bracket here, because just a reminder, this has got an invisible negative 1 here. So everything is going to become the opposite. So that one there is currently positive, so it will become negative. This one's positive, so it will also become negative. And this negative will become positive. So we've got 4x squared, and I'm taking away these last brackets as well. Plus 12x plus 7 minus 4x squared minus 4x. And then we've got plus 1. All of this comes to, because 4x squared minus 4x squared is 0. We've got 12x minus 4x is going to become 8x. So we've got 8x. And then we've got 7 plus 1. And that's going to get me to 8. And this time here, similar to the first question, so an even number had a factor of 2. Divisible by 4 will have a factor of 4. So we're going to factorize this. And luckily for us, they've got a factor of 4. So if we go divide by 4, we've got 2x plus 2. Because we've got a coefficient of 4, that factor or multiple of 4, we know for sure that this expression, or the difference between these two squares, is always going to be divisible by 4. So let's state that here. So these 3 dots mean therefore, as this expression has a factor of 4, it can always be divisible by 4. There we go. So we're done with this question. We are now on to question number 55. We've got a path around a swimming pool. The path has 3 rectangular sections. You could break your rectangles up in different ways, but I'm guessing they meant this bit, and then they probably meant this bit here, and then this bit down here. But everyone's triangle will look slightly, or everyone's rectangles will look slightly different. All the measurements are in meters, so we've got some units to worry about later on. And we've got a total area of 14. So this one, and we've been asked to find the width of x. So you can see x popping up here, here, and here. That's the width of the path. Okay, so just generally speaking, I know, let's say this part here is number 1, this part is number 2, this part's number 3. I know the area of 1 plus the area of 2 plus the area of 3. I know all of these are going to come to 14 meters squared. That's because that's what they told us. We now need to come up with an expression for these 3 parts. So area number 1, up the top there, it's the 3 meters going across this way and the x meters going up and down. So the expression there is going to be 3x. So we've got 3x. We're going to add on our expression for number 2. This is x wide, and just under here is 16. But up here, because we've lost an x up here, this part here will be 16 minus x. So that there will be x times 16 minus x. And our final one along the bottom, we're going to have a similar issue. We've got an x taken out here. That means the remaining portion must be 4x. So it's going to be 4x times x, which gets me to 4x squared. Sorry, my diagram's getting very messy, but we won't need it now that we've got the 4x squared, and that's equal to 14. So we've now got an equation. It's a quadratic because we've got an x squared there. So we're going to expand, we're going to simplify, and we're going to try and solve this quadratic. So expanding here, we've got this times this. So we're going to have 3x plus 16x minus x squared plus 4x squared minus 14 equals 0. So I've moved this 14 over to the other side by subtracting. That's where that minus 14 came from. Now I'm going to simplify. We've got 3x squared here. So we've got 3x squared. This lot becomes 19x. So we've got plus 19. We've got the minus 14, and that there comes to 0. So we've got a quadratic with a coefficient of more than 3, or more than 1, in this case 3. So we've got a couple options. Are there any common factors here? In this case, no. So we're going to have to use the grouping method. So we're going to start off with by going 3 times negative 14. That there is equal to negative 42. I now need to figure out, well, what adds to this 19 and multiplies to that negative 42. And there's a few different combinations that might be tempted to work, but in this case, we're going to have 21 and negative 2. So 21, negative 2. Just going back a little bit because I realize my working is missing that little x there in the middle there. So we had 21, negative 2. So 3x squared. Just noticing this 19x, I'm going to split it up based on these two numbers. So I'm going to have plus 21x minus 2x. And just a reminder, that comes to 19x, which is what we had before. And then we've got minus 14 equals 0. I'm now going to factorize the first pair and then the second pair. So that there, they've got a 3x in common. So that leaves me x plus 7. The next two have a negative 2 in common, also leaving me with x plus 7 equals to 0. I've got the same bracket twice, which means I didn't stuff up. So I'm going to write that common bracket here, x plus 7, and then the leftovers, 3x and minus 2, they're going to form the second bracket, 3x minus 2. And that there is all equal to 0. I'm now going to solve them separately. So my first equation, x plus 7 equals 0. My second equation, 3x minus 2 equals 0. We've got x1 equals negative 7. And this one here, this one's going to be a bit trickier. We're going to have 3x equals 2. And I'm really running out of room here. But luckily, x2 is equal to 2 over 3. So we've got a nice little fraction there. At this point here, if you stopped, you're not quite finished. You're getting a merit at this stage here. The issue being this negative 7 here. Because what path is ever negative 7 meters wide? That's not how measurements work. It's always got to have a positive number. So because x must be greater than 0, and that's because measurements are always positive, we must ignore x1 equals 7. Therefore, x is equal to 2 over 3 meters. And you can leave it as a fraction. I wouldn't suggest getting into decimals here because you'll have that recurring 666 stuff. So we'll leave it as it is. We are now on to question number 56. This one's a goodie. It's just a whole mishmash of algebra. We've been asked to solve that. So let's start probably by factorizing the top. And that's going to get me to x plus 5, x minus 2. We can then factorize the bottom. That there is going to be x plus 5, x minus 3, and we know all of that's going to be equal to 3x over 2. We didn't do anything to that other side of the equation there. I've got a common bracket on the top and the bottom, so I can cancel these out. So I know that x minus 2 over x minus 3. Oh, sorry, I've got plus 3 actually. That should be plus 3. That's going to be equal to 3x minus 2. I'm now going to cross these. Turn the division into multiplication, so we've got 2 bracket x minus 2. That's going to be equal to 3x bracket x plus 3. I was hoping to avoid this, but if we expand this 3x in x, we're going to get 3x squared, so we're going to get into a quadratic again. So we've got 2x minus 4 equals 3x squared plus 9x. So this one's going to be messy. 0 is equal to 3x squared. And then minus 2x off here was going to make that 7x minus 7x. And then we've got plus 4 because that negative 4 is going to become positive. I now need to factorize here, and I'm going to think about using the grouping method again. Before we do that, I just realized I think I made a math error. We've got 9x minus 2x, so that should become positive 7x, right? Hopefully I've got that right. Let's get back to the grouping method. We've got 3 times 4 is going to be 12. What adds to 12 and multiplies to 12 adds to 7. And that's going to be 3 and 4 again. By chance, it's the same as the first and last of the numbers. That is not always the case. We now split up the 7x into 3x and 4x. So 3x squared plus 3x plus 4x plus 4, that equals to 0. Just a reminder, 7x, and we've got 7x there. It's just been split up based on those two numbers. I'm now going to factorize the first group and then the second group. So 0 will be equal to 3x, because they've got a 3 and an x in common. We're then going to go x plus 1. The next lot, they've got a 4 in common, and then the bracket also being x plus 1. I've definitely done this right, because I've got 2 x plus 1s in my brackets. So 0 will be equal to x plus 1, that's the common bracket. The leftovers, 3x plus 4, I'm going to put that in the second bracket. So I've factorized. I can now get to the actual solving bit. So my first answer will relate to the first bracket, so x plus 1 equals 0. And my second answer will relate to my second bracket, 3x plus 4 equals 0. I now solve both of them. That'll get me my two answers. So we're going to go minus 1, so x. The first answer of x is equal to negative 1. And the next one, we're going to go minus 4. So that means 3x will be equal to negative 4. And I've then got divide by 3. So x will be equal to negative 4 over 3. And that's my second answer of x. Final question for us in this video, question number 57. Let's have a read through. So we've got the surface area of a cylinder. And they've actually got the formula for it down there. None of that other stuff's useful. So we've been told the surface area is 33 pi and the height is 9.5. So what we know from this is we know that big A will be equal to 33 pi. This pi is going to be a bit annoying, but we don't need to calculate pi because we don't have calculators in this exam. And our height is equal to 9.5. So let's jot down the formula we're given and let's substitute both of those values into it. So A in this case is equal to 2 pi r, and then in brackets we've got r plus h. So we know A, we're going to take that away, put in 33 pi, and we know the h over here, that's going to become 19.5. And just a reminder, we've been asked to find the radius, so the r will be left over. So 33 pi will be equal to 2 pi r, and then we've got r plus 9.5. And we're looking to solve here. The first thing I'm probably going to do is I'm just going to divide by pi here, because that will cancel it out. So all the pi's will be gone. It'll just make my life a little bit easier. So 33 will be equal to 2r, and then we've got r plus 9.5. I'm now going to expand my bracket, so 33 will be equal to 2r squared plus 19r, and I'm going to take away 33 from both sides, so I can get 0 at the subject. So 2r squared plus 19r minus 33. So this is now going to be a bit annoying because the numbers are quite big. So I need to go 2 times this negative 33. That gets me to negative 66. So I now need to figure out, well, what adds to 19 and multiplies to that 66. So there's a few numbers going through my mind, but 66 is divisible by 3, which would get me to 22. So I'm thinking it's something to do with 22 and 3. Because it's positive 19, if we make that 3 negative, 22 minus 3 gets me to that positive 19. So a big fan of that. I'm now going to, maybe I'll scoot back on over here. I'm now going to split my 19r up into those two parts. So 0 is going to be equal to 2r squared plus 22r minus 3r minus, sorry, I nearly wrote 66, but minus 33. I'm now factorizing using the grouping method. So that's going to be 2r in common, will be leaving me with r plus 11. And then we've got a minus 3 in common, leaving me with r plus 11. Perfect. Same bracket coming up twice, so I know I didn't do any silly math errors on my way. 0 equals r plus 11. That's the common bracket. The leftovers, 2r and minus 3, they're going to form the second bracket, 2r minus 3. We can now solve both of these because they're going to be our two answers. R plus 11 must equal to 0, and 2r minus 3 also 0. So we're going to do minus 11 here. So r1 will be equal to negative 11. And here we've got plus 3 on both sides. So 2r equals 3. R2 will be equal to 3 over 2. So this one here, we need to think about the context. We always have two answers for r, so you need to think, do they both make sense? And in this case, again, we can't have a negative dimension, similar to a previous question we've done. Negative 11, yeah, you're never going to get a tape measure and tell me something's negative 11 centimeters. So we're going to ignore that answer, meaning R2